Hi guys, welcome to lesson 2-6, ratios, rates, and conversions. Our objectives for today are that I can find ratios and rates, and that I can convert units and rates. Our essential understanding: you can write ratios and find unit rates to compare quantities. You can also convert units and rates to solve problems. So, our vocabulary for today: a ratio, it compares two numbers by division. It can be written one of three ways: either A over B, 1 colon B, or by saying A to B. So any of these three ways say the exact same thing. A rate is a ratio that compares quantities measured in different units. A unit rate is a rate with a denominator of 1 unit. And a conversion factor is a ratio of two equivalent measures in different units. And we're going to use all of these later on today. But first, let's just start with comparing unit rates. Problem number 1. And I want to know which one of these stores has the best deal. Store A, which sells 2 shirts for $25. Store B, which sells 4 shirts for $42. Or Store C, which sells 3 shirts for $30. So we're going to start, and we said to find unit rates, we want a denominator of 0. So I'm going to start with Store A is $25 for 2 shirts. 25 divided by 2 is $12.50 per shirt. Okay. Now we have Store B, which is $42 for 4 shirts. So I do $42 divided by 4 shirts. 42 divided by 4 is going to be $10.50 per shirt. Lastly, we have Store C, which is 3 shirts for $30. 30 divided by 3 is going to be $10 per shirt. So which store has the best deal? It's going to be Store C, because it has $10 per shirt. That is the best deal. All right, letter B. Store A sells 2 sweaters for $60. And Store B sells 3 sweaters for $80. Which store offers the better deal? So we need to compare what is the price, the unit rate of each sweater. So Store A is $60 over 2 sweaters, which is $30 per sweater. Right, because 30 is 30 over 1. Okay. Our second store was $80 over 3 sweaters, which is $26.66 repeating cents, or which would be rounded to 67 in the store, per sweater. So which is our better deal? It's going to be Store B, which has the better deal. All right, I want you guys to pause the video and go ahead and give these two at the bottom a try on your own, and then resume it. Store A sells 3 different sized boxes of rice. One, which is 72 ounces, for $6. We have a 42-ounce box for $4.78, and a 28-ounce box for $3.84. So we're going to check and see which one of these is a better deal. These are actual prices for boxes of rice. So for the first box, we've got $6 over 72 ounces, which is going to be 0.083 repeating cents. All right, our second box was 4.78 over 42, which equals 0.11. And our third one was 3.84 over 28 ounces, which is equal to 0.137. So which one of these is the better deal? It's going to be the larger box. All right, letter B asks us, a store is selling Tide detergent in multiple sizes, and we want to know which one is the better deal. So we've got $6.89 for a 50-ounce bottle, which is equal to 0.1378 when you divide it. We have $9.94 for 100 ounces, which is 0.0994. And lastly, we have $23.99 for 150 ounces. 23.99 over 150, which is equal to 0.16. So let's look at our units. We've got dollars per ounce here. So we've got $13.78 per ounce. 13.78 cents per ounce. We have 9.94 cents per ounce and 16 cents per ounce. Which one is our best bet? It is going to be our second one. So we can't always assume that the bigger volume is always going to be the better price. When you go to the store, the most common place you're going to see this is in the grocery store. And most stores have on the corner of their price tags a price per ounce for each product. So you can compare which sized package is your better bet. Which one is the better deal for your money? All right. Problem number 2 is going to look at converting units from one measurement to another. So we're going to start off, we've got 1,250 centimeters, and we want to convert that into meters. So we're going to use the fact that 100 centimeters is equal to 1 meter. All right, now we've got 100 centimeters and 1 meter. So we're going to start off, we're going to write these as ratios, and I want you to be very deliberate with how you write them. First of all, unlike most equations we do, we are going to include our units when we do these conversions. So we write what we're starting with, 1,250 centimeters over 1. All right. Our next thing that we're going to write is this conversion factor. We know that 1 meter is equal to 100 centimeters. So if I have centimeters in my numerator, where do I need to have centimeters in order for it to cancel out in a fraction? It's going to be in the denominator. So 100 centimeters for 1 meter. And now we have our units canceling out. Centimeters cancels out. And we are left with only meters. So now we need to multiply. When we multiply fractions, we go straight across the numerators and then straight across the denominators. So we have 1,250 over 100, which when we simplify is 12.5 meters. I want you to write every single unit conversion you ever do for this class exactly like this. Okay? Now, 23 kilograms to grams. I know the fact that 1 kilogram is equal to 1,000 grams. So we're going to start. We have 23 kilograms over 1. And we are going to multiply that by, we want kilograms in the denominator, so our units cancel out. 1 kilogram is 1,000 grams. Metric system is easy. So 1,000 times 23 is 23,000. over 1 times 1 is 1. So that's 23,000 grams. All right. All right, number 4, we've got yards to inches. 4 yards, 6 inches, and we want to convert that into inches. So let's start by converting yards. So 4 yards. We're going to multiply. Well, I know that a yard is 3 feet. All right, so our first units cancel out. And I've got feet. Is that what I'm trying to get? No. So I need to do another conversion. I know that 1 foot is equal to 12 inches. So our feet cancel out. We're left with just inches. Is that what I'm trying to get? Yes, it is. So now I just need to do my multiplication across. 4 times 3 times 12, and that's going to be 144 over 1. So that's equal to 144. But remember, we had another 6 inches when we started, so 144 plus 6 is equal to 150 inches. All right, so 4 terabytes, and we're converting it to megabytes. So we start off with 4 terabytes over 1. And we are going to go from terabytes to gigabytes, because I know that 1 terabyte is equal to 1,000 gigabytes. Terabytes cancel. Are we to our goal unit yet? No, not yet. So we need to use one more conversion. I know that 1 gigabyte is equal to 1,000 megabytes. So now we just need to do the multiplication. 4 times 1,000 times 1,000 is equal to 4 million over 1, which is 4 million megabytes. All right, I want you guys to try problems A and B, and you will come back with the answer. All right, so letter A, we are converting 90 feet into yards. So the first thing we need to do is start off with 90 feet over 1. And I know that there are 3 feet in a yard, so 1 yard is on top. All right, do my units cancel? Well, feet and feet cancel out because feet divided by feet cancels. We have our target unit, which is yards, so we have 90 over 3, which is equal to 30. Okay. So, next one that we want to take a look at is 525,600 minutes, and we're converting this into years. So we start off 525,600 minutes over 1. Our first conversion, I can go from minutes into hours. So I'm going to do 1 hour is 60 minutes. Well, still not there yet. So I'm going to go 1 day is 24 hours. Am I there yet? No, not there yet. So I need to go 1 year is 365 days. Okay, now I got days involved. I got years. All right, sounds good. So let's check our units. Minutes cancel. Hours cancel. Days cancel. I'm left with just years. So now I need to do my multiplication across. 525,600 times 1 times 1 times 1 is 525,600. And 60 times 24 times 365 is 525,600. Divide those two out and we get 1 year. So 525,600 minutes converted into years is simply 1. And if you were a fan of Rent, you would have already known that how do you measure a year? There you go. All right, problem number 3. We are going to convert between systems. All right, so metric conversions are nice and easy because we're multiplying by factors of 10. Well, then you've got that crazy standard imperial standard system that we use in the United States, which is absurd. All right, so we're going to start off. One World Trade Center, the New World Trade Center, is 1,776 feet tall. How many meters tall is it? And we're going to use the fact that 1 meter is 3.28 feet. So we start off like we did the previous one. We have 1,776 feet over 1. We're going to multiply that by our conversion factor, which is 1 meter per 3.28 feet. Check our units. Feet cancel out. So we're left with meters, which is what we want to have. So we have 1776 over 3.28. 1776 divided by 3.28 is equal to 541.5 meters. So it's not just dimensions that can be used to convert. We can convert currency, so the exchange rate on money changes daily. As of Sunday, $1 American is equivalent to $1.23 Canadian. And I want to know how many Canadian dollars can I get for $250 American. So we're going to start off with 250 over 1, and we'll just say dollars. And our first conversion factor, we know that $1 American is equivalent to 123 Canadian. All right, so right now the American dollar is a little stronger, so our dollar signs cancel out. We're left with dollars Canadian. 250 times 1.23 is equal to $307.50 Canadian. All right. So right now the dollar is strong compared to the Canadian dollar. That is not always the case. These rates fluctuate. All right, next up we've got the amazing Hubble Space Telescope, which if you were in my class, you've seen some of the cool pictures from. The Space Telescope weighs 24,500 pounds, and we want to know what is its weight in kilograms. And we're given the ratio that 0.454 kilograms is 1 pound. So we start off with 24,500 pounds over 1. We multiply by our conversion factor, which is 0.454 kilograms per 1 pound. Let's check our units. Pounds cancel out. One's in the numerator, one's in the denominator. So now we multiply straight across and we get 11,123 kilograms. 11,123 kilograms. All right. All right, next page in our notes. The last page we have is converting rates. So remember, a rate was measuring two different units. So we've got an athlete that is running a sprint of 100 feet in 3.1 seconds, and I want to know at what speed were they running in miles per hour. So not only do we need to convert the unit in the numerator, we need to convert the unit in the denominator as well. So 100 feet in 3.1 seconds. We start that off as our ratio, 100 feet over 3.1 seconds. Make sure your S looks like an S and not a 5, like mine. All right, so the first thing we need to do, well, let's start with that 100 feet and work towards miles. So I know that 1 mile is equal to 5,280 feet. Let's check our units. I now have miles per second, miles over seconds. See why I'm being a stickler on the units? Are we there yet? Do we have miles per hour? No. So now I need to convert from seconds to minutes. So I'm going to start with 60 seconds in the numerator, because that's how we cancel out seconds. We need to have one in the numerator, down here and up here, per 1 minute. All right, are we there yet? Our seconds canceled out, but we still have miles per minute. Not quite what I'm looking for yet. All right, so our next unit, let's go from minutes into hours. And I know there are 60 minutes per 1 hour. Our minutes cancel out. Now I have miles per hour. Is that what I want? Miles per hour. So remember, we are multiplying straight across our fractions. So 100 times 60 times 60 is 360,000. Okay. Over 3.1 times 5,280 times 1 times 1 is 16,368. So when we divide that, we find it is 21.99 miles per hour. Okay. I want you guys, especially when we're dealing with these rates, set up your ratios exactly like I've shown you, working straight across your page. All right, letter B. A student ran 100 yards in 12 seconds. We want to know at what speed did the student run in miles per hour. So we're going to be doing the same or a very similar conversion. We have 100 yards per 12 seconds. All right, well, let's convert our distance first. 100 yards, I know that 3 feet is 1 yard. And then we just use this conversion in the previous one. 1 mile is 5,280 feet. So now if we look at our units, our yards are canceled out, our feet are canceled out, we're left with miles per second. Okay, great. Still not quite where we want to be. So we're going to multiply by 60 seconds per 1 minute. Still not quite there. We're going to multiply by 60 minutes per 1 hour. And now we're where we want to be. Our seconds cancel out, our minutes cancel out, and we are left with miles, it's the only unit remaining in the numerator, per hour, the only unit remaining in the denominator. So now we multiply 100 times 3 times 60 times 60, which is 108,000 over 12 times 5280 times 1 times 1 times 1, which is 63,360, which when you reduce is 17.05 miles per hour. Okay. Letter C, we have Aroldis Chapman, who holds the record for the fastest recorded pitch in Major League Baseball at 105.1 miles per hour. We want to know what is the speed in feet per second. All right, the first step, we know 105.1 miles per hour, so 105.1 miles per 1 hour, and I want to go to feet per second. So the first one, let's go from miles into feet. So I know there are 5,280 feet per 1 mile. That gets our distance to where we want it to be. I know that I have 1 hour, which is 60 minutes, and 1 minute is 60 seconds. Let's check our units. So miles cancel out. Hours cancel out. Minutes cancel out. And I'm left with feet per second, which is what I want. So when you multiply straight across, you get 554,928 over 3,600. When you simplify that, you get 154.15 feet per second. To give you an understanding of that, Aroldis Chapman's fastball arrives at home plate less than 1 second after he releases it. From the moment it leaves his hand to the moment the catcher catches it, it is less than 1 second. Think about that next time you watch a baseball game. All right, last problem. We have the SR-71 Blackbird, which is the world record holder that we know of for the fastest air-breathing manned aircraft, and it's held it since 1976. Here's a picture of it at the Smithsonian Udvar-Hazy Center in Washington, D.C. I highly recommend. Pretty awesome to see. It is going 3,529.6 kilometers per hour. And I want to know, what is the speed in meters per second? So we're going to start off with our known quantity, which is 3,529.6 kilometers per hour. All right. Well, our first conversion, let's get that distance into meters. So I know that there are 1,000 meters in 1 kilometer. So units. All right, we're down to the meters that we want. Now we just got to get time into seconds. So there is 60 minutes in 1 hour. And there are 60 seconds in 1 minute. Let's check our units again. Hours cancel out. Minutes cancel out. We're left with meters per second. Multiply our numerator straight across, and we've got 3529600 over 60 times 60 is 3,600, which when you reduce is 980.44 meters per second. And that's your final answer. All right, so make sure that you fill in your level of understanding, rate your understanding of this lesson, identify any confusions or questions you may have over this lesson, and go ahead and write your summary of what you learned today. And we will see you in class tomorrow. Have a good night.